All right, so I'm live here with US certification, certified developer. I'm going to get into this thing and just share my screen. There's a lot to cover today. So here we go. All right, I'm going to get into the docs for the developer. Here we go. And we're going to get into container services, love containers. Let's dive right into it. And what we can cover here is this concept of why do we care about containers and containers versus hardware virtualization. This is a very, very common one that many people ask me, like, why have a container versus a VM? And then microservices, which are the use case for containers. Okay, let's get into containers. Like, what are they? What do we do with them? So one of the things to consider is that in the old days, before there were shipping containers, it was just a mess because there was all kinds of different weight and size, et cetera. And it took a long time to transport goods. But now, I think it was in the 1950s or so, we had the introduction of standardization. And now when you put these particular containers on a ship, then it's more efficient to load, unload, stack. And so that's the same concept. That's one of the analogies here, is that by having a uniform size, it's going to be easier to and structure to ship things. And so what's inside of a container, and in particular, it's a standardized unit of software. So it would be runtime engine, application code, system tools, system libraries, and in particular, the runtime is associated with the code itself. So you can think about containers as being a method of the operating system virtualization that allows you to run the application and all the dependencies in an isolated way as a process. So container is a lightweight standalone software package that contains everything a software application needs to run, including the application code, runtime, system tools, system libraries, and all the settings together. And a single server can host several containers that all share the underlying operating system's kernel. And so these could be part of a huge application, or they could even be separate applications that are completely isolated. But the fact is that you can see everything that's inside of a container. Now let's talk about the difference between hardware virtualization, and one of the things that we can see about how applications have been developed in the 1960s, it would be, bare metal servers all the way up into 98. When I graduated from college, actually. So I graduated right as we were going to virtual machines. And with virtual machines, you could have the host server, the host OS virtualization platform, and you would actually go through and run many different versions. So you could have Windows, you could have Linux, all running on the same machine. One of the things that's a bit of an issue with a bare metal server is that you either have something running 0 or 100%, and that's a problem. And by using virtual machines, you're able to actually share things around quite a bit, package things around. But there is some kind of a redundancy in that you can have the same OS installed, let's say 3 different times, when you don't need that, right? You just need the library. And that's why containers are just a more fine-grained unit. And so with containers, you don't have to have the operating system, the libraries, all that stuff installed over and over and over again. You can just have the application itself installed. And because they're highly portable and isolated, they're a lot quicker as well. So you'll see a pretty big speed difference when you're actually using containers. So what about Docker versus other virtualization platforms? So Docker is a lightweight container virtualization platform, and it provides tools to create, store, manage, and run containers. And it will integrate with automated build, test, and deployment pipelines. So that's a big thing to be aware of, is that it's really a part of the reason why containers are so popular, So what are some of the benefits? Portable runtime. Also you can package the application and the dependencies in just a file, and the file is immutable as well. You can create a container image and go anywhere the Docker is supported. You can run application versions with different dependencies, and there's better resource utilization and efficiency. Now, in terms of the container terminology, these are things that you'll hear a lot, and they can be a little bit confusing because a lot of the names sound the same. But a Docker container is created from a read-only template that's an image. But a Docker container is an instance of an image, and the images are built from a Docker file. And that's just a plain text file that describes all the components that are inside of a container. And that's one of the advantages, is you can just look at a Docker file and it tells you exactly what's inside. You also, though, can use images that are stored in a public or private container registry, and you'll see that when you're using, ECR, Amazon's container registry, for example. So an image is based on usually another image, and that's an advantage because an expert, let's say a Python core developer, could have built the Python core image and you're just utilizing it, or an AWS image would be used by an AWS developer, and you could just utilize the majority of it and customize it a little bit. And so, if you could install, let's say, a web server application, and that's one of the advantages as well, is leveraging the power of the experts, which it really wasn't available with VMs. There really wasn't this concept of an expert would configure the VM for you. There's a little bit of it, but not at the scale that we're seeing with containers. And with an example here, this would be a Docker file. You could say from Ubuntu latest. It would grab the latest stuff from Ubuntu, and you just put in whatever it is you need to put in inside of your container. So this is a good one to actually play around with, to see if you understand how containers work, is try like a hello world. Now, if you wanted to do Java, right, there's another example here. We could say from with JDK version 8, copy a jar file and put that into a directory, and then go ahead and run the Java application, right? And this would be another example of what you could do. Another one would be, let's say with CentOS, you could use the base CentOS 7 image, go through and do some updates to it, install a web server, expose port 80 web server, then copy some scripts, give them some permissions, and then have an entry point here that runs this shell script. And in particular, what's happening is on this read-only image layer, you would be going through all these different steps. So each of the line of the Docker file adds a layer to the image. Now, some of the commands that are very, very common with Docker are important to know. So you have Docker build, and that would build an image from a Docker file. I use that quite a bit, and I'll put, let's say, Docker build dot, just to build like an image that's based on a name that I haven't specified. If I just want to play around with something, there's also Docker images, and this will list all the images that are on the machine. There's Docker run, which would run an image. Docker PS, this would list the running containers. Docker exec, which would run a command in a container. Docker stop, which would stop a running container. Docker start a container. Docker logs, view container log output. Docker port would be list container port mappings. And then Docker tag would be tag an image. And Docker push would be push image to a registry. Docker inspect would be inspect the container information. And in summary, the Docker images versus containers, some of the things that you can do for it would be, you could actually, really have a read-only immutable template that's highly portable. You could use that as the base for a lot of things you do. And it's also important to know that a container is an instance of an image. So you can spin up many different versions of it based on that same image. And each container is a thin read-write layer on top of the existing image when it's instantiated. And this is what makes the process of spinning up a container so fast versus a virtual machine. And Docker uses a copy on write system. So when the files are changed, when the file changes are written to a read write layer of the container, the underlying image would remain unchanged. And that's why there's multiple containers that have access to the same underlying image, but still have their own data state. When the container is deleted, this writable container is also deleted. So microservices is probably the next follow-up here, which is why would you use containers? Well, microservices are probably one of the best possible scenarios for containers. And I would say that monolithic versus microservice architecture, you can see in a monolithic architecture, uh, there's a lot of things that can go wrong because they're all interconnected. So if one of the processes on a machine is spiking, the entire thing has to be scaled, and this causes issues. And the monolithic architectures also have a risk for availability because things are all wired together. But if you had 3 applications running in a microservice architecture, each one can be completely separate and scaled separately, and they can also be updated and deployed separately. And that really is helpful. So you don't have to deploy the entire system just because you made a change to one component. And so what are some of the characteristics of a microservice? Well, decentralized evolutionary design. So you want to assume you're going to change it constantly. The smart endpoints and dumb pipes. There's no enterprise service bus. The data is not transformed when it's going between services. The independent products, not projects. So in contrast to, let's say, a waterfall project model, you would think of microservice as a separate product, designed for failure. So, everything's always going to fail. So if you design things in that way, you're going to have a huge win in terms of using microservices. Disposable is also a huge win for microservices. You want to make sure that if something's going to go wrong, you can, shut down what's failed and spin up a new instance, and you can start fast, fail fast, release any file handlers. The deployment pattern is like a circuit breaker as well. So in a traditional architecture, servers are named, deployed, evaluated, and removed, and the workloads are changing, and the resources are temporary. So these are some of the things that you get when you get disposable. Now, development and production parity. This is another great example of how containers come in handy. Is that containers can make it really simple to have development, testing, prod environments, and this is a facilitation of the DevOps principle. So Amazon Container Services. So the big challenge with managing containers is, how do you actually move things around? Or you have a host that has maybe hundreds of containers, and in production environment could even have thousands of containers. And so one of the things to be aware of is how do you intelligently manage the availability, resilience, performance of those containers. And so this is why you need to have some kind of a management platform. You can't do this on your own. So Amazon ECS, Docker Swarm, Kubernetes, these are all examples of management platforms. And they give you things like services for networking, persistent storage, security, monitoring, logging. Numerous options exist like Amazon Elastic Container Service. There's native tools like Docker Swarm, open source platforms like Kubernetes. All of these management platforms, also Amazon EKS as well. So if we look at Amazon's custom Elastic Container Service, it's a highly scalable, high-performing container orchestration service that works with Docker containers and enables you to run and scale containerized applications on AWS. And you can manage a cluster of these things as well. The ECS system has its own scheduler, and so that allows you to integrate with third-party schedulers. It's also tightly integrated with other things like IAM and also CloudWatch and Route 53. So here's, at a high level, something to consider when you're thinking about ECS is that first there's a container image that's pulled from a registry, and that registry can be Amazon Elastic Container Registry, ECR. which is one of the services that I use quite a bit, or it could be a third party or private registry. Next up, you define an application. So you would have, a container image with necessary code and resources. When you're ready to bring it online, you could select one or two different launch types, and Fargate launch types could provide a near serverless experience. With Fargate, you can focus on tasks and the application architecture. The EC2 launch tool is also useful because you can have more control over the infrastructure that supports your task, and you can create and manage clusters on EC2. And you can also mix and match launch types as needed within your application. And finally, you can use ECS to manage your containers as well and scale up for availability. So Kubernetes is another one to be aware of, and there's actually Elastic Container Service for Kubernetes, which is called Amazon EKS, and it's an open source container management platform, but Amazon manages it for you, which does provide a lot of wins. And if you are using Kubernetes, you can run on any kind of containers application, and also AWS services that need to run Kubernetes in the cloud can work inside of this. And a couple things to be aware of in terms of EKS is a certified Kubernetes conformant, so you can use existing tooling and plugins. So it's not like a morphed version. And Amazon EKS will automatically set up secure and encrypted channels to your worker nodes as well, which is pretty nice. So they manage something that's very complex for you. Now, in terms of EKS as your container management service, you could provision an Amazon EKS cluster and deploy worker nodes for your cluster, and you can connect to EKS and run Kubernetes applications. Amazon ECR is a really nice service because it's built directly into Amazon, and it provides a fully managed cloud-based Docker image registry, and you would store, manage, and deploy the Docker container images. And Amazon ECR can integrate with both Amazon ECS, the homegrown container management system, and the Docker CLI, which means that you can have a very simplified workflow and push your container images to ECR by using the Docker CLI for a dev machine. And then when you want to go to production, you just pull it directly into ECS or other services like AWS App Runner, which is something I use quite a bit with ECR. And you can also programmatically access ECR as well. And it's pretty nice. There's a nice prompt that tells you how to build everything, like AWS, ECR, create repository, and then Docker build -t, you tag it, and then you'd authenticate to it, and then you would push that image directly into your own repository. So it is a very user-friendly experience, in my opinion. And once you're in ECR, you have the ability to push to other services, like, for example, the App Runner. So that's really it from a nutshell. What I would recommend people do as a follow-up is to go into AWS, play around with Cloud9, and push a container into ECR, and then go ahead and hook that up to App Runner or to ECR or both. And that will give you a great overview of how to use containers for the AWS platform. So next week, I'm going to cover SQS and SNS, two services I love to experiment with as well. All right. See you next week.